Hello, my friends, and welcome back to another exciting week in General Conceptual Science Online. I'm really excited to talk to you this week about a topic I am extremely passionate about. You see, our geosphere, it contains all the rocks and minerals found on our planet, and Earth scientists use the geosphere and the concept that drives it as a way to communicate on how dynamic our planet truly is. So last week, we learned about minerals, and we realized in order to get to a mineral, we need to be able to have chemical bonding occur, and that the chemical bonding is then expressed in the mineral and how it forms. So let's actually step up and scaffold into more complex topics dealing with the fundamentals of earth science. And we can do that by just looking at the natural world around us, taking a look at that dynamic geosphere. The rock cycle is a way for us to conceptualize that dynamic nature of the geosphere. You have igneous rocks that are forming through cooling magma. You have metamorphic rocks which change under extreme pressure and heat. And then you have my personal favorite, the sedimentary rocks, the ones that form through the accumulation and deposition of sediment. So, how do we think about rocks? Well, we think about them as they are the foundation of our planet, the ground we walk on. Sedimentary rocks are all around us, and they give us wonderful insight. I was actually driving around this weekend, and I noticed this really great rock outcrop. It has a great succession, stratigraphic beds, and that's the term that earth scientists use, where we actually have a bed of one type of rock up here, then we go into a lower bed and several other beds before we get down lower, and each of these beds are distinct from each other. How are they distinct though? Well, we can actually take a look at some of the rocks and be able to use analytical techniques to conceptualize and better understand and explain how these rocks got here. This rock outcrop is actually located just outside of Mount Storm, West Virginia. In fact, actually, the cars that you hear driving across the bridge right here are actually those that are driving on Highway 48, also known as Corridor H, as they are heading towards Thomas and Davis in that direction. What we're working on is actually some of the members of the broader Carboniferous-aged Kanawha Formation. The Carboniferous is actually been age dated to be before the time of the dinosaurs, but it's a very important unit of time for those that live out here in West Virginia, because this is when we get our massive coal deposits. So when we take a look at the outcrop, we notice that there's actually several different kinds of rocks. And in fact, I collected a few. So this is one of the first rocks that I acquired. I can actually take a look at this sedimentary rock and take a look at how you have grain textures. It feels a little coarse. I see bits of calcium into it. I see little fragments of shells. So this tells me that this rock, which came from all the way at the top, may have actually been deposited in an early river channel or close to a shoreline because of the concentration of calcite. Remember, calcite is a mineral that forms along aquatic environments. The banding and layering, the texturing, I'll show it right here. You see on how orderly that is? To me, that seems like it's a river channel. Going lower into the outcrop, I find these massive slabs of coal, West Virginian coal. And we can use the same analytical techniques we use to identify that this is coal. And so the large masses of coal tell me that that layer was a swamp at one point. As I move lower in section, I can find slabs of shale with fossil plants into it, fragments of them. And so this actually tells me that the shale was at one point very quiet. It allowed for that early plant life to develop. And then over time, more and more plants form. They die. They start to cement together and carbonize and form that coal. Then as the waters recede, then river channels carved out the rest of the landscape. And so basically understanding how to identify rocks out in the field is a very informative exercise to be able to apply your conceptual knowledge in the course. So that's what we're going to be doing this week. We are going to take the same idea, the same analytical techniques we use to identify minerals, but this time we're going to apply to rocks and use different characteristics. In lab, you're going to have some of the boxes of rocks that I've prepared for you digitally with some of my observations to assist you in being able to make a much more improved identification or diagnosis. And then you're going to reflect on it. What kind of information, what kind of treasures and conceptual knowledge can you gain from the world around you in the geosphere? Again, if you have any questions, please reach out. You can set up a video chat with me, swing by my office, or send me an email. Have an excellent day on planet Earth.